So this is the 6th video in the forces topic, and in this video we will be discussing Newton's third law, which defines how objects interact. Newton's third law is the law of equal and opposite action, and essentially it says that whenever I push on something, it will push back on me with an equal force. So whenever we deal with Newton's third law, we're dealing with objects in contact. So we're dealing with contact force. In this situation where the object is sitting on the ground, we know the bookshelf is in contact with the floor. So there is a contact force between the bookshelf and the floor. Here we know that we have the weight force acting downwards, and from our previous videos we know that we have the normal force acting upwards. Here the normal force is a contact force. It's the perpendicular contact force, as it always acts perpendicularly to the plane of contact. But weight is not a contact force, because you will always have weight if you have a gravitational field. You don't need to be in contact with something in order to have weight, but you can't have a normal force unless you're in contact with another body. So if we analyse the forces acting on this system, we have, as always, a net force. So by Newton's second law, that net force is equal to the mass times the net acceleration of the object. And we also know the net force, by definition, is the sum of all the forces acting on the object. So if we look back to our diagram, we can see that we have two forces acting on the bookshelf. We have the normal force acting upwards, and we have the weight force acting downwards. We know also that our bookshelf is not moving, so the net acceleration of the system is 0. So that means we get the following equations. Our net force is equal to 0, which is equal to n minus w. And if we rearrange that equation, we can see that we get that the weight is equal to the normal force. Or in other words, we have equal and opposite forces acting. So we get Newton's third law by an analysis of the contact forces. And that also gives us another way of looking at Newton's third law, as that contact forces must come in pairs that add to 0. So what about this situation, where we have a man who is leaning against a bookshelf but not falling? So in this case, the man is exerting a force on the floor but at an angle. And then by Newton's third law, the floor is exerting an equal and opposite force back on the man. So by now, we should be pretty good at vector resolution. So we can see that such a force at an angle is made up of our two contact forces. We have the force in the direction parallel to the floor, and the normal force perpendicular. And the parallel force we know is friction. So identifying the contact forces is a good way of identifying when Newton's third law is acting. But in order to solve the situation, or to solve the problem, we need to be able to resolve the contact forces into our normal forces and our friction forces. If two objects in contact will always exert an equal and opposite force on each other, how do things move? So for example, in the picture, if the man pushes on the bowling ball, he exerts a force on the bowling ball. If Newton's third law is correct, that bowling ball must exert an equal and opposite force on the man. We know from experience that when this happens, the bowling ball will move and the man will stay still. So why is that? And you can put your answer in the comment section below the video.